Academy. Today we'll be looking at probability. We'll be looking at probability part 2, and here in this probability we'll be looking at the Venn diagram, what we call the Venn diagram. Okay, so in this probability we'll be looking at solving probability questions from the Venn diagram. Okay, so without much ado, let's begin. Let's listen to our tutorial and then get some insight, and then solve some questions. Is that okay? As usual, we get some tutorial, we get an insight, and then we explain a little bit more detail, and then we solve some questions. So that's what we have today. Now we'll be looking at the Venn diagram, but before then, let's take a look at this tutorial.
In this tutorial, we're going to look at using Venn diagrams in probability situations. And unusually, we're going to go straight in with the question. We'll look at the key points before we come to question 2. So in this question, we're given a Venn diagram. Here it is. It's got the numbers 1 to 9 in it, in various sets. 2, 4, 6, 8 in set S, and 3, 6, and 9 in set T, and the rest of them outside those sets, but still in the universal set. Remember the notation. And we're asked to write down the elements, first of all, of S intersection T. And I hope you understand this notation. If you don't, go and look at the tutorial on Venn diagrams and set notation. But it is that overlapping area there. And the way we write down elements is we put them in a curly bracket like this, and there is just one in this set. It is the set containing the element 6. Now what about the next one? S union T. Well, union is everything in both sets together, like that. Okay, so anything in those 2 blue shaded areas, or the 3 blue shaded areas if you want to. And we can write them down in any order. So I'm going to start with the left hand area. That's 2, 4, and 8. The middle area is just 6, and we only write down 6 once, because it only appears once, even though it's in both sets. And then 3 and 9, and that is the complete set of S union T. And now we get on to the probability bit. A number is chosen at random from this diagram, and what is the probability that the number is in the first set we dealt with, S intersection C, given that it is in S union T? Now that given that in the middle means we are in conditional probability territory. Okay, and we need to know about that. So let's have a look at the last key point on the left. To find the probability of A given B, let's say, we find the number of elements in A and B, in other words in the overlap, and divide by the number of elements in B. So let's do that. So following that rule, the probability of something being in S intersection B, given that it is in S union T, is, well, how many elements are in both of those things? Let's actually look at the list of elements rather than the Venn diagram. We can see that it's just the 6 that's in both, and so the number of elements on the top is 1. And then how many elements are there in the second thing, in S union T? Well, there they are. There are 6 of them. So the probability is simply 1 out of 6. And if you think about that intuitively, that makes a lot of sense. We're in S union T, 6 elements, just one of them is in S intersection T, so 1/6. Now the second one we haven't written down the elements for, so let's do it a bit more formally. So we've got probability of T, given that it is in not S. S dashed means not S, and so that'll be the number of elements that are in both T and not S, and divide that by the number of elements in not S. Well, let's have a look at that on the diagram. So we've got T is this one here, and then not S is, if I shade in a different colour, is everything outside S, which is all of this, and we're looking for the number of elements in the overlap between my shaded area, and that is 2. Okay, just the 3 and the 9. And then how many are in not S in my green shaded area? Well, let's count them up. I can see 1, 2, 3, 4, 5. The 3, the 9, the 1, the 5, and the 7. So 2 out of 5. And that is that. Right, let's move on to question 2. But before we do that, let's just have a look at the key points. You can see in question 2 that we're given a lot of information about GCSE students. I say a lot of information, actually we're only given one piece of information about each student, and that is whether they have a GCSE in French or Spanish, and we call that a characteristic. Another characteristic might be whether they're male or female, but we're not given that, so this is a one characteristic question, and we're going to use a Venn diagram to summarise the information. If we had been given two characteristics, so their GCSE choices and their gender, we'd have used a two-way table, and that is in a separate tutorial. So what do we do? Well, we draw a Venn diagram. You can see I've sketched one out already here. It's got two circles because, of course, there's only a choice between French and Spanish. We're going to fill in the information. We're going to use unknown letters if necessary, but only if necessary. We're going to calculate any figures we need to, and then we're going to go on to the probability bit as we did before. So let's do that for this question. Now, the first thing we're told is there are 100 students, so I know the total in this rectangle here is going to be 100. I can't put that in yet. 68 have a French GCSE. Can't put that in yet either because I don't know what's in the overlap. 33 have a Spanish GCSE, and the only thing I can put straight in is that 10 have neither. Okay, so we'll put 10 in there like that. Now, the thing that's causing me the problem is the overlap. So I'm going to give that a name, and I'm going to call it X. And as soon as I do that, well, all of this bit must be 68, so the bit in the left-hand part of it must be 68 minus X, and similarly, in the S circle it must be 33, and so this bit is 33 minus X. And now the 100 comes into play, because I know that all of those things added up must equal 100. So I can say 68 minus X plus X plus 33 minus X plus the 10, so that's all four numbers there, all four regions, must total 100. And now I can do the adding up, and I get 68 plus 33 is 101, plus 10 is 111, so I've got 111, and then minus X plus X, well, they cancel out. Minus another X just leaves me with minus X, and that's equal to 100. What do I subtract from 100? From 111 to get 100? Well, 11. So X must equal 11. And now I need to do the probability. And the probability, I've summarised all my information, I've worked out the unknowns, let's put those in on the diagram in fact. 68 minus 11 is 57, there's 11 in the middle there, and 33 minus 11 is 22, and I've still got the 10 on the outside there. Okay, now the probability is a given probability again, as it was in the first question, so we're going to use the conditional probability formula. So let's write that down. We want the probability of both, so the overlap, if you like, given that they do Spanish. Okay, well that's going to be the number in the overlap, so where they have both and Spanish, well that's just both, so that's 11 over, well how many are there in Spanish altogether? We were given that number earlier, it's 33. So 11 over 33, which is just 1/3 if you cancel it down. Okay, so one characteristic problems, you use Venn diagrams.
Okay, so I believe we will. Don't worry, we will see the tutorial with our class. Okay, so that's it. That's for the tutorial. The tutorial is explaining how Venn diagram is used. So it's also a reminder for the set theory you've studied, set notation you've studied in your earlier chapter, I think chapter 10 of the Igcse course of study. So this is a little bit of revision for the Venn diagram, and now we've included probability to the Venn diagram, how you use probability to solve the Venn diagram problem. Okay, Venn diagrams, what do we use them for? To do, okay? They help us to show two or more characteristics of a situation that always overlap. That always, there are situations in life that overlap. For example, if you go to school, you choose subjects that you want to do. You see some students will choose physics, chemistry, biology, maths, English, and whatever. Some students will choose business. Maybe they will not do chemistry or physics, but they will do maths, English. So you see maths, English overlap with so many students. Almost all the students in the school, they do maths and English. So even if you're choosing chemistry, biology, physics, and all the likes of science, some other students will choose economics, business, accounting, maths, English, and so on and so forth for the business stream students. So what is overlapping? Then for the humanities students, they choose geography, history, environmental science, maths, and English. So like this, if you take a look at this, what is overlapping? It's the maths and English, meaning every student in the school is going to be taking maths and English. So maths and English will be the overlap, for example, if we consider two students. Okay, for example, if we consider two students, right? If we consider two students, let's say student A and student B. This student A and this student B. So there's an overlap. This overlap is what is common between both. Is what is common between both. Okay, this overlap is what is common between both of them. Student A and student B. So the overlap is what is common. Maybe what they do together. What is common. So we can call it X here, for example. So this is an overlap. So set or Venn diagram is a diagram that shows given information and how this information overlap one another. As this information, meaning how we can show the commonality between two information. So a Venn diagram helps to show commonality between two given information. And that commonality is the overlap. What is common between two things? What is common? Like the HCF, you've heard highest common factor. For example, I can give you 6 and 12. Or 6 and 18, 6 and 12. Let's start with 6 and 12. We can ask you to find the factor between this, the HCF, the highest common factor. This is 2 times 3. The HCF is the overlap. The highest common factor is the overlap. Is what is common between both of them. Okay, this is 2 and 2 multiplied by 2 multiplied by another 2, right? Multiplied by 3, sorry. So the overlap here is 2 and 3, the product of 2 and 3. So this is an overlap, and this one as well, because it's common between both numbers. So the commonality is 2 times 3, which is 6. So what it then means is the HCF is the commonality, the highest factor that is common to both numbers. That's what we call the overlap. The highest common factor the highest factor that is common to both numbers, which is 6. What it means, 6 is here, 6 is also in 12. If you break the factor of 12, you have 6 in it. If you break the factor of 6, you have 6 in it. So the highest common factor is 6. Okay, so that overlap, that thing that is common to two information or two data is called the overlap. And that diagram that shows an overlap between two information is called the Venn diagram. It's called the Venn diagram. So I hope we get this concept a little bit clear. So we can move on to, like we've already drawn that. So that overlap is called, in set, is called intersection. This overlap is called the intersect. Okay, so you hear about union and intersection in set theory. In set theory, you hear about union and intersection. That overlap that I've just talked about is called intersection. Intersection of two sets. Okay? So for short, we say interset. For short, we just call it interset. So the interset is given with a symbol. And that symbol looks like letter N. It's given with a symbol, and that symbol looks like letter N. So if we're given two sets, let's say set A is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let's say this is set A. Okay, we will not spend too much time because we're not dwelling on set. And set B is 2, 4, 5, 6. Okay, set B is 2, 4, 5, 6. So if this is set B, so we can begin to find the interset. Interset is it's what is common. Okay, we always use squares bracket to close set. Okay, so the interset is A. The interset is A. Set A overlap or interset. Set A interset. Okay, we can show it with a different moment. So set A interset, see, interset set B, meaning there's an overlap. True or false? We can ask you to tell, is there an overlap? Is there an interset between set A and B? Meaning, is there any number common to both of them? Yes, there is 2 common to both of them here. Another number, there's 4 common to both of them. And there's 5 common to both of them. So these are the overlaps. These are called the overlaps are called the interset. What is common to both sets? 2, 4, and 5. 2, 4, and 5 is the overlap, is the interset. Okay, so they will always ask us to recognize or to determine the interset. What's common to both sets? Then another commonly used, just as revision, is the union between two sets. Union, and the symbol is like this. So union, which has a symbol like letter U, it's actually what is common, what is everything that is in set A and set B. Union of two sets is like the sum of everything in set A and B. Whatever is here, so if I ask you to shade, you go to shade here. And remember, in set or in Venn diagram, we always close it up to show the universal set. To show the universal set. So once you close it up with a rectangle, you are saying this is the symbol for universal set. You are saying the universal set equal to whatever it has been defined to be. So the universal set encompasses set A and set B, encloses set A and set B, right? So universal set encloses set A and set B. So the union in this regard is what is everything that is inside A and B, not the interset. Interset is only the overlap. The interset is only this overlap, what is common between A and B. That's the interset. But union is a different concept entirely. The union of set A and set B means everything here. You can shade the whole set A and B. As long as you don't go out of set A and B. That's the meaning of union. Everything that is in A and B is the union between the two sets. So if we are asked to list, give the union A union B, for example, if I write A union B, list the element of A union B. If we are asked to list the element of A union B, we're going to list all the elements here, 1, 2, 3, 4, 5, but we're not going to repeat the number twice, even if it appears here and here. As long as we measure the number once, it's enough. 1, 2, 3, 4, even if it's not on both sides, even if the number, as long as it appears on any of them, you're going to list the number. 5 and 6, meaning you'll be asked to list every element that is in set A or in set B. You have to list all of them out. That's the meaning of union. That's the meaning of union. So I hope this has given a very good clue. Then when we say A prime, because when we are dealing with the probability, we need this basic concept. We need this basic concept. What is A prime? Okay? What is A prime? Meaning everything that is in universal set but not in set A. So if they give you all the elements from outside this universal set, maybe we put some numbers outside here, 7, let's say 7 is here, outside, 8 and 9 is also outside, okay? That completes the universal set. So if we ask you to list the universal set, you're going to list all the number. Starting from A, B, all the number 1, 2, 3, 4, 5, 6, 7, 8, 9, all of them, and 10. All of them, you have to list them. That's what makes up the whole universal set. But now if they ask you for A prime, what it means, you're going to list all the elements that are in the universal set, but they are not in A. What is in the universal set that is not in A? So what is it? The elements that are in universal set that are not in A. You go to set A, you see 1 is mentioned, 2 is mentioned, 3 is mentioned, 4 is mentioned, 5 is mentioned. So those one cannot appear in A prime. A prime will be every other element in the universal set that is not in set A. So meaning starting from 6, 7, 8, 9, and 10. These are A prime. So when they say A prime means complement of set A. The complement, A complement. The real meaning, the prime is just a language we use. But the real meaning is complement of set A. The complement of set A. Complement of set A is called A prime. Complement, okay? So they are everything in the universal set that are not in set A. You cannot measure any element in set A when you are dealing with A prime. Meaning we are asking you the complement. What complements A? What is it that is in the universal set but not in A? If we ask you for B prime, similarly, you're going to measure all the elements that are in the universal set but they are not in B. They must not be in B. They must not be in B. Including what is in the overlap is in B. So you must not mention them. It means here, without considering the overlap, you measure all the elements of A and what is outside A. But you must not measure anything that is in B when they ask you for B prime. Okay, so these are the basic I want you to get, or these are the basic I want before we go to the probability aspect of what we have today. Okay, before we look at the probability aspect. So that's the basic. Now let's take a look at looking at the probability. When do we start to look at the probability? How do I use the Venn diagram with conditional probability? Okay, conditional probability. We're going to see it when we see a problem. Okay, we'll be able to tackle it when we see a problem. So we say, for example, if students are studying German or Spanish or both of them, you might want to know the probability that a student who studies Spanish also studies German. You may want to know the probability. What probability is it that a student who studies Spanish is also doing German language? Okay. Another conditional probability questions that you can be faced with are often but not always introduced by the expression given. Like given that, they always use those expressions, given that, but some of them they don't use this expression. For example, find the probability that a randomly chosen student studies German, given that the student also studies Spanish. So the question can come like this. These are called conditional probability. You say find the probability that a randomly chosen student studies German, given that the students also study Spanish. Is they do German, given that they also study Spanish. So we're going to look at how these type of questions are answered. The answer would be the number in the Spanish and German. That's what's come up to both of them. What's common? The intersect, the overlap. The overlap over the students that are studying Spanish and German. The total number of students doing Spanish and German. Okay? So that's what it's going to look like. For example, look at this question. The Venn diagram below shows the number of students at a college studying Spanish and German. So these are 12 students studying Spanish, 21 students doing German, 4 students doing both of the subjects. And 8 students are doing neither. Meaning 8 students, they're not doing Spanish, neither do they do German. They're not doing any of the two subjects. Okay? A student is chosen at random. Find the probability that they study Spanish but not German. Find the probability, that's the first question. Find the probability that these students, they study Spanish but they don't study German. If you include this, it means you are including German. So if you want to find this probability, you're going to start with students who do Spanish only. Although the whole of this circular part is for Spanish. However, if you include this 4, you are also including for German because the whole of this circular part is for German. These 4 students, they do Spanish, they do German. So if they ask you a conditional probability that you should find the probability of the students who speak Spanish but not German. Not German. So this not German exclude this 4. You're not going to put this 4. So number of students who study Spanish, because this is what it is. This is what it is. What it is. We just have to do what we have to do, right? So this is Spanish. This is Spanish. Students who speak Spanish, and this is for students who speak German. This is for students who speak German, right? So here, 12 students speak Spanish only. Spanish only. Here means Spanish only. Does not include German. Then the 4 that has been given characteristically depicts or shows the students who do both. Students who do both subjects, right? So here, this 4 is for those who do both subjects. Now, here, the German, number of students who study German be given to us, right? To be 21, and 8 study neither. Here, we have 21, and then we have a universal set. Every time we enclose the Venn diagram, then it becomes, we have included the universal set. So we have a universal set, and our universal set, the symbol for universal set is like this. A symbol like this, okay? This is the symbol of universal set. And 8 students are out here. This 8 student can be written anywhere, outside the 2 circle. Can be written anywhere, meaning they do none of these subjects. Okay, so this is what it is. Now, it's a find the probability of the number of students that study Spanish but not German. So P, probability of Spanish but not German. Okay, not German. They don't do German. Okay, so this probability will be number of students who do Spanish only. So Spanish only is what? 12. Right? Spanish only is 12. And then over the number of students who study the total number of students, over the total number of students. The question should have given us probably the total number of students. Even if the question did not, we can sum up everything. 12 plus 4 plus 21 plus 8. So that will give us the total number of students. So if you are asked to find the probability of students who study Spanish and not German, you will look at, don't say 12 plus 4, which is 16. If you write 16 here, you've included 4 students who also do German as a language. Because these 4 encompass those who study both Spanish and German. So in this case, we're not going to include this. We say 12 for students who study Spanish only over the total number of students. And the total number of students is 12 plus 4 plus 21 plus 8, right? 12 plus 4 plus 21 plus 8. So what does that sum up or amount to? We find the total. 12 plus 4 is 16. 16 plus 1 is 17. 17 plus 20. 17 plus 10 is 27. 37. 37 plus 8 is 45. So this gives us 12 over 45. 12 over 45. The probability is 12 over 45. We can still reduce this if possible because this is not the simplest ratio. Okay, this is not the simplest fraction. So we can reduce this. 3 can go into 12. If 3 goes to 12, we get 4. If 3 goes to 45, 3 goes to 4, we get 1. Remainder 1. We put the 1 here, becomes 15. 3 goes to 15, we get 5. So our answer becomes 4 over 50 as the probability of students who study Spanish only. Okay, so that's the first question. Probability A, I put it as A, question 1A, or probably question 2A. Okay, let's say 2A. Probability of those who study Spanish only. Now let's see the second part of the question. The B part of the question says the probability that they study neither Spanish nor German. Probability that they study neither Spanish nor German. Now, number of students who don't do both of the subjects is 8, right? Number of students who do not study neither. Neither means they don't do any of the subjects. Probability of neither subject is, it means none of the students is taking any of the subjects. So we already know from the Venn diagram that 8 students do not study any of the 2 subjects. 8 students in that for the class of 45 students, neither S nor P nor G, none G. So none of them is doing any of these 2 subjects. So the probability will be number of students who don't study any of the subject over the total number of students. Number of students who don't study any of the subjects. So we go to the Venn diagram. We see there are 8 students in the Venn diagram who do not study any of the subjects. So the 8 students over the total number of students gives us the probability. So 8 over 45. 8 over 45. Right? 8 over 45. This one we cannot simplify because 2 can go here but 2 cannot go here. 3 cannot go here but 3 can go here. So there's no common factors that can simplify this. So we leave our answer as 8 over 45. Right? Now we go to the C part of the question. Let's see the C part of the question. What is it that they want us to do in the C part of the question? The probability that they study Spanish given that they study German. The probability that they study Spanish given that they study German. Okay? Here, this is a conditional probability. Probability that they study Spanish given that they study German is what is common to both of them. They study Spanish given that on the condition that they study German. So students who study both is this over the probability of German, which includes some students who study Spanish. So this is a conditional probability. This type of probability, we extremely have to be careful. We extremely have to be careful. See, the probability that they study Spanish, given that they study German. So the probability that they do both is 4. Probability that they do both is what? Is 4. So the C part of this question, probability that they study Spanish only on the condition that they study German, such probability that they study Spanish on the condition that they study German, this probability is given as the students, number of students who study both subjects, which is 4, the overlap, the intersect, over the students who study German, while that includes a little bit of students who study Spanish, which is 4 over 25. Here, we're going to add this and this. Because of the language, given that they study German, given that. So we're going to include this and this. Is that okay? So we say this becomes 4 over 25 in this regard. 4 over 25. Probability that the number of students who study Spanish given that they study German. Is that okay? So let's see the D part of the question. Okay, that's for the C part of the question. We say here, 4 of those students study German, also study Spanish. That's why we got 4 on top. Given that, in the question, tells us that it is only out of those study German. It is only out of, given that they study German. Given that they find the probability of number of students who study Spanish, given that they study German. If you listen to the English, if you analyze the English, find the probability of those who study Spanish, given that they study German. Meaning, those Spanish students must be students who must study German. Those students who are studying that Spanish language must be those who also study German. So those who study both of them is 4. And those who study Spanish and study German is 25. Which means 4 plus 4, this 4, which includes Spanish, plus the 21, we study German. So this gives us over 25 in this case. Now, the last question, the D, The probability they study German, given that they study Spanish. Now, vice versa now. This probability that they study German is also going to be 4. Given that they study Spanish, we're going to sum up that of Spanish. Probability is a find the probability that they study German, given that they study Spanish. So the D part of the question, the D part of this question, what we're going to do is that the probability that they study German, given that they study Spanish. Study German, given that they study Spanish. In this case, we find the common number of students, which is 4. Both, the overlap, the intersect. 4 over those who study German, but on the condition that they do Spanish first. On the condition that they do Spanish first. So that takes us to the Spanish number of students on the Spanish side, which is 12 plus 4. And 12 plus 4 will be 16. 12 plus 4 is 16. So in this case, we can simplify this because this can be simplified. This can be simplified. 4 divided by 4, we get 1. 16 divided by 4, we get 4. So in this case, we get 1 all over 4 if we reduce to the lowest term. If we reduce to the lowest term, we get 1 all over 4 for this case, for this probability. So that's it for this question. So we can get more problem and look at more example and try as much as we can to solve those examples. We're going to look at some questions. Here we got like 2-3 questions for us to try our hands or lay our hands on, and then we see how we move around that. Is that okay? So before we eventually go to relative probability now and next listing. Now let's take a look at this question. In a class of 30 students, so we already know that the universal set is 30. So if I'm going to draw the Venn diagram, I'm going to have my universal set to be 30. In a class of 30 students, 15 students study Spanish. 15 students study Spanish, and 3 of the Spanish students also study German. 3 of them. So they've told you those who do both. 3 of the Spanish students also do German. So those who do both, it's 3 who do both subjects. The overlap is 3 in this question. Now it says 7 students study neither Spanish nor so 7 students study neither. Right? Draw the Venn diagram to show the information. First and foremost, 15 students, 30 students are in the class. Question number 3. We say 30 students are in the class. We have students study Spanish and German. A lot of students study this language because of migration purpose. Okay. So I know you'll be wondering, oh, people study German language. You're very familiar with English and French and Arabic. Okay? But student people also study these other languages. Now let's take a look at this. Let's take a look at this. This is Spanish. This is German. This is the overlap. The overlap is always X. But in this case, they gave us the number. They say 3 students. So here, the universal set is 30. Universal set is 30. So there are 30 students in the class. Once they say there are 30 students in a class, universal set is 30. Once they say there are 100 students in a class, universal set is here 50 students study Spanish. So here is not totally 15. It's supposed to be what? 15 minus what? If you want Spanish only, to be 15 minus 3. Right? It will be 15 minus 3 if you want Spanish only. Right? If you want Spanish only, to be 15 minus 3. Why are we minus 3? Because why we minus 3 is because out of the 50 students, 3 of them has also studied German. So if you want only Spanish, those who speak Spanish, but those who study Spanish, they don't do German, you have to subtract this. Hence you get 12 here. Hence you get 12 in this place. You get 12 here. And they've given us 7 students study neither, right? 7. Right? That was what the question said. Let's double check. 7 students study neither. Okay? 7 students study neither. So 7 here. Here we don't know what it is. We can call it Y if you like. You don't know how many students are here who do German only. Who study German only. So we can easily find that, right? Can easily find that. Because we already know here only, here only, here, and we equate it to 30. So the first question, but let's see what the question is going to ask us to do. It said draw the Venn diagram. That's the first information. Okay, to draw the Venn diagram, we must find the number that is here. High is here 8. High is this place 8. We must find. For the Venn diagram to be complete, we must find that number. How to do? You say 12 plus 3. This 12 here plus this 3 plus this y plus this 7. Everything equal to 30. So you say 12 plus 3 plus y. You know we don't know the number of students who study German only. That's why I put y. We put y so that we can find it. Plus 7. Those who study neither equal to 30, right? Equals to 30. So we solve this. So you add this and this, you get 15. 15 plus 7, you get 22. So I have 22 plus y equal to 30. 22 plus y equal to 30. Now you have this. Find y. You make y the subject by saying y equal to 30 minus 22. You move 22 to the right, then you subtract. You say 30 minus 22. 30 minus 22, you get 8. So you can see why y was 8. Why that place? The students who study German only is 8 students. The reason why they're 8 students is because we've carefully calculated it, right? So it's 8. Those who study German only is 8. So this place is 8. So the Venn diagram, we can strike this off if you like. So the Venn diagram will be 12, 3, and 8 here. You can strike the y off if you like. And then this 7 outside. So that's the first thing they asked us to do, the A part of the question, is to draw the Venn diagram. And when they say draw the Venn diagram, you have to show the number in the right proportion, the right places, and the right position. So we succeeded to do that. 12, 3, 8, and 7. So we draw the Venn diagram. Now let's see the B part of the question. What they're going to ask us to do. The B part of the question say, use the Venn diagram to find the probability that a student selected at random from the class studies Spanish but not German. Probability that I study Spanish but not German. So here we're going to look at those who study Spanish only. You know, the whole Spanish is here, which is 15. The whole Spanish. But we're not looking for the whole Spanish because if you include this overlap, these 3 students, they also do German language. So we're not going to include them. We're only going to consider those who do Spanish only. Students in the class that do only Spanish, but they don't do German. So we're not going to include these 3 because the question conditionally told us that you should use the Venn diagram to find the probability that a student selected at random from the class studies Spanish, but not German. If you include these 3 for Spanish, you are including German language. So they say but not German. So this must not be inclusive. So you only select Spanish only. So there are 12 students who study Spanish only. So the probability of students who study Spanish but not German, the B, probability, okay, the probability of students who study Spanish and not German. So if I say not German, I can say German prime. Okay, Spanish, then not German, meaning must not include German language. Okay, in the number of students. Spanish but not German. That probability will be equal to number of students who do Spanish only, which is 12. 12 from here, which is 12, over the total number of students in the class, which is 30, over the total number of students in the class, okay, which is 30. So you can always simplify this. 6 the highest common factor between 12 and 30 is 6. So you use the HCF to divide top and bottom. So 12 divided by 6, you get 2. Right? 12 divided by 6, you get 2 on top. And 30 divided by 6, you get 5. So our simplified version of the answer is 2 over 5. That's the probability. If you live like this, sometimes you are correct, but sometimes they deduct like small mark, 1 mark, half mark. always good to put in the simplest form. But if you don't know how to put in the simplest form, you can leave your answer as 12 over 30. Okay, so that's that for the second question. Okay, that's that for the second question. Here we have three cases of probability. You'll be given a Venn diagram. Okay, before we look at it, okay, you'll be given a Venn diagram, question number 4. Find the following probability. So we're going to find the following probability, P of A, probability of A. So we have A, B, C. Let's draw that, and 9 is out. Let's draw this set and quickly see what we can do. Okay, let's quickly draw this set, these three sets. Quickly, set A, set B, and set C. Set A, set B, and set C, each overlapping each other. Okay, so let's quickly see this, what it is, for what it is. Let's see for what it is. So here is set A, here is set B, and here is set C. If you close it, you get a universal set. Let's assume, you see, I've shadowed it. See the boundary? This is the universal set. So it's like the rectangle covering it. So here, we call it the universal set, right? We call it the universal set. Assume that we've drawn the rectangle bordering it. Now let's fill up the number. 9 is 9. I think 9 was outside. Okay. Now let's see what is in A. The elements in A, set A, we have 3 here, 1, 8, 5. Okay, 3. We have 3 here, 1 here, 8 here, 5 here. Then let's see the other ones. 1, 8, 5. Then we have 4 here, 2, 8. 4, 2, 8. 4 is here. 2 is here. 4, 2, 8. How come? Oh, 8 occur a second time. 4, 2, 8. Okay, so this is our set. Now, the first question is find P of A. Right? Let's check. Is that what they asked us to find? It says find the P of A. So P of A is everything that covers A, right? Everything that covers A, all the elements in set A. Whether they overlap or not, we go to total them up, right? And then we go to total everything up. Find the probability of element in set A. That's the question. So let's sum up the elements in set A first. So we say 1 plus 8, that's 9. 9 plus 5, 14. 14 plus 3, that's 17. So element in A, or number of elements in A. So P of A, probability of A. Probability of A is equal to the number of elements in A. Number of elements is in set A over the total number of elements. Over the total, right? Over NA over total. We can just say over the total. Okay, we can say over the total. Or over universal set. Okay, let's put over universal set. I think better. Total means universal set. Okay, over the universal set. So this becomes, we've summed the NA, we say 17, right? We summed it up to be 17. So let's take that and work with that. So this becomes the element in set A, 17, over the whole universal set. Remember, we've not summed the universal set. Universal set, since here is 17, since here is 17, now let's find the total element in the universal set. Knowing that 9 is on the 9 there. Here we have 17, and then plus 4, 17 plus 4, we get 21, plus 2, 23, plus 8, we get 31, plus 9, we get 40, so over 40. So this will become 70 over 40. That's the probability of P of A, probability of elements in A. Meaning number of elements in set A over the total number of elements in the whole universal set. That's the meaning of probability of set A. So in Venn diagram, they can be asking you probability questions. So don't be confused. When they say P of A, meaning we can shade, if possible, we can shade this place. P of A. Find the element in this place, which is 17 over the total elements in the whole set, including the neither. Including the neither. Is that okay? Yeah, let's shave it properly. Let's use it so that we not miss the numbers. Okay? So we have the elements in the set A over the total number of elements over the total element in the universal set, including the neither. You know, remember this one encompasses the whole of this place, the universal set. Is that okay? Is that okay? Okay, now let's take a look at the B one. Let's take a look at the B. The B, remember this is the A, question 4A. Question 4A. Let's put question 4 here. Question 4A. Now let's take a look at question 4B. What is 4B asking us to look for? 4B says we should find the A intersect B intersect C, meaning what is common, the intersection of the three, the probability of the intersection. So the probability of the intersection is the point of intersection between the three over the total. So let's go to what we have is the intersection. This way now we use a different color to highlight this. The intersection of the three, not the intersection of two, intersection of the three is this place that we've highlighted green. The intersection of the three. Because the question says we should find P of A intersect B intersect C. So the question says find P of A. Find the P means probability. Probability of A intersect B. The intercept of A and B and intersect C. Where is there an intersection between the three sets? Where is the intersection between the three sets? Is here. The green shading or the green highlight. This is the intersection of the whole three. See, this intersect is between A and B only. This 5 is between A and B only. This intersect 1 is between A and C only. This intersect 2 is between B and C only. But this intersect A, 8, is the intersection of A and B and C. So when they ask you to find the probability of A intersect B intersect C, it means the number of elements in A intersect B intersect C. So the number. So this probability is equal to the number of elements in the three intersection, the three overlap. That means the number of elements in A intersect B, A intersect B intersect C, over the total number of elements in the whole universal set. Over the total number of elements in the whole universal set. Over the total number of elements in the whole universal set. Remember universal set, I say we write it like this. Over the total number of elements in the whole universal set. Okay? So once that is given, we simply define our answer to be what is the number of elements in the whole three intersect? 8. The number of elements in the 3 intersection is 8. So this 8 divided by the total number of elements. This 8 divided by the total number of elements, which is 8 over 40. 8 over 40. Right? And we can simplify this by saying 8 can divide 8, 8 can divide 40. So 8 is the highest common factor, which is the HCF. So we say we go into both of them, we divide both of them with the 8. 8 divided by 8, we get 1. 40 divided by 8, we get 5. So our answer will remain 1 all over 5. Our answer to this probability will become 1 all over 5 because we can reduce it to the simplest term. Some people will divide like multiple times. They can say here divide by 2, they get 4. And here divide by 2, they get 20. It becomes 4 over 20. And then you see you can still divide this again. You can do that. You can do it step by step. You can still divide here by 2, you get 2. And then you divide here by 2, you get 10. And then you still go again. You can see the two numbers can still be divided. Here divide by 2, you get 1. Here divide by 2, you get 5. That's if you can don't divide it once. If you don't know the common highest factor, you can break it down step by step till you get to the lowest term upon which you can no longer divide. Okay? So that's the B part of the question. Now let's see what they see, if there is C question, and what the C question wants us to do. C says we should find the probability of B prime intersect C. B prime intersect C. Okay? B prime intersect C. Now, let's go and do that, and then we find that probability. We find that probability. Right? B prime intersect C. 1 minute. B prime. The C part of the question says we should find the probability of B prime. Probability of B prime. B prime. Well, I already explained when I started. I was explaining this prime. I call it complement of a set. That's the name. That's the name. The prime is just my language, okay? When I call it B prime, it actually means complement of set B. What is in the universal set that is not in set B? Okay, what is in the universal set that is not in set B? So wherever we go to shade, wherever we go to highlight, must not include the B, the set B. Whatever we go to highlight must not include the set B, but it will include C and any other part. B prime means any T, S that does not include the set B. That does not include set B in this set B in this regard. So B prime intersect C, we've used the blue color, right, to highlight what is given there. The B prime intersect C, because here must not include the B. See, anything B cannot be, because they call it B prime. B prime means anything in the universal set but not in B. So when you are highlighting, you cannot highlight any portion of B, whether be it intersect with any other part. As long as it cuts across B, cannot be inclusive. Cannot be inclusive. We only go to take the intersection of A and the space of C. And that's it. That's it. And then we add them together. That's 5. Here is 1. Here is 4. If you sum them up, it becomes 5. So that probability will be number of elements in A and C. So you say this will become equal to the number of elements. The number of elements in set A and C. You can say A and C. Number of elements in A and C. The number of elements in A and C. Or we can, is it A intersect C? Which language we can use? Not only the A intersect C. Because A intersect C is this. A intersect, and you cannot say A union C because it will include everything here. So let's just say number of elements in A and C, but not in B. Okay, A and C, number of elements in A and C, not in B, A and C, not in B, must not be in B. Anything in B is not part of it, not in B. Not in B, over the total number of elements. Over the total number of elements. Okay, over the total number of elements. Which is over the number of elements in the universal set. Over the number of elements in the universal set. Over the number of elements in the universal set. So if you sum up A and C that is not in B, you get 1 plus 4, which is 5. So here we say this is equal to 1 plus 4 over 40, right? This is equal to 5 over 40. And 5 over 40, we can simplify to the lowest term. 5 is the highest common factor, HCF, meaning 5 can divide 40 and 5 can divide 5. So this one divided by 5, we get 1. 5 divided by 5, you get 1. 40 divided by 5, you get 8. So this probability will be equivalent to 1 all over 8 for this question. Is that okay? So these are the high-level IGCSE questions they can go or they can give you. And when it comes to a Venn diagram with probability. Is that okay? Now let's see if there's any other one. Okay, here we have the probability of A union B. A union B. So we're going to look for where A and B intersect only. We're going to look for probability of A union B. We must not include C only. It will include C, but not C only, because A and B cut across C. So let's go and highlight that place. Probability of D, probability of A union D, probability of A union B, probability of A union B. Union means that all the elements is set A and set B. All the elements is set A and set B. Is it A union B or A union C? The question says probability of A union B. Okay, A union B. Now let's take a look at what we have. Probability of A union B, we have to find the number of elements in A union B. Number of elements in A union B over the total number of elements over the universal set. Over the number of elements in the universal set. Right? Over the number of elements in the universal set. Quickly. Now let's take a look at that quickly. Let's take a look at that. We go to our Venn diagram, A union B. We choose another color. A union B will be everything on A and B. Everything on A and B. Everything A okay, A union B. Okay, so A union B is what we have highlighted with the pink color. A union B is what we have decided to highlight with the pink color. So now let's take a look at the numbers now. Let's take a look at the numbers quickly. Let's take a look at the numbers. So how many numbers are there? Let's sum them up. How many numbers are there? Let's sum them up. So we'll still go back to the diagram. How many are there? A union B is 3 plus 1, that's 4, plus 8, 12, plus 5, 17, plus 290, plus this, 27. Right? I guess it's 27. 27 over 40. Yeah, 27 over 40. So the sum is 27 over 40. So let's get that. So once you get this concept, you'll be able to solve any of these type of questions in the exam. 27 over 40, I don't think we can reduce this one. We can simplify it because 2 cannot go to 27 and 5 cannot go into 27. We have to find a common number that can go into 3 can go here but cannot go into 40 without a remainder. So we leave this as it is. So I think that's for this question. I don't think they still have. Okay, they still have. They have the E part of the question, A union B union C, meaning everywhere. We have to shade everywhere. A union B union C, we sum them up, and then we find. Now find the probability, the E question. The E question, I love the way they went extensively in bringing what is possible in the exam. So find the probability of A union B union C. Because they ask us for intercept A, B, and C, right? Now they're asking you the probability of A union B, union C, A union B, union C. So if they ask you this probability question, what will you do? You say the number of elements in A, union B, union C. It is the number of elements in A, union B, union C over the total universal set. Over the total universal set. The number of elements in set A, B, and C, A, union B, and C over the total universal set. Over the total universal set. Remember, universal set is just like this, the total sum of all the this. So we put the numbers. So we got to count the union, or we got to highlight. So in this case, it's actually everything. So we don't need to do another highlighting. It's everything, all the whole shaded area. We got to now combine the whole shaded area, but the only thing that is not going to be counted is the 9. Is the 9. The only thing that is not going to be counted is the 9 that is outside. Okay, because it's not part of the A union B union C triangle. Okay, so with this A union B union C, we're going to count all the numbers. Without counting, I'll just say 40 minus 9. That's 41. So if, without counting, I already know here it will be 41. Okay, why? Because the whole is 31. 31. Because I already know here is 40. The whole, including this 9, is 40. So if I subtract 9 away from everything, I'll get the 31. So if you want to do, we can do the counting. 3 plus 5. 8, 8 plus 8, 16, 16 plus 1, 17, 17 plus 4, 21, 21 plus 2, 21 plus 2, 23, 23 plus 8, that's 31. So that's it. We add all the numbers in A union B union C, which is 31, over the universal set. Over the universal set. So that's how to do probability. Remember, probability is always something over something. And the answer must be less than 1. Because if you divide, because you can see they are all proper fraction. You cannot have improper fraction. If you have any proper fraction, if you divide, it's going to be 0 point something if you press in a calculator. Answers of probability must be less than 1. Or maximum equal to 1. Maximum equal to 1. You cannot get probability answers greater than 1. Okay? Cannot get. You solve a probability problem, you get 1 point something, 2 point something. It means you're wrong. You have to figure out what you did wrong, and you have to look at the problem again. So I think with this, we may have probably come to the show. Okay, here we still have a problem, but this one I think can be, with what we have done, I think we're good to go. I can just explain what it is. Here is x, here is 3 plus x, right? So here is x. So to find what is here, you have to subtract x, subtract this, and subtract this from this. You get only here only. To get here, you have to subtract minus x, minus 3, minus x, and you get here only, and so on and so forth. So 0 is neither. And you have to get show that x is 5. So you solve this and you'll be able to get x is 5. And one way to do that is to sum everything together. Add everything here together. Okay, and equal to the universal set. Probably they must have told us 55 member equal to 55. Say this plus this plus this plus this plus this plus this plus 10 plus 0. No need to say plus 0 equal to 55. Equal to 55. Okay, once you do that, you'll be able to get the value of x, right? Right? We do it right. So, okay, I explain it from what is already solved. Okay, so what we do is to just say find the value of x, or show that x is 5. So what you do, you say 30 plus, we can add the numbers first. 30 plus 10 plus 12 plus x plus 3 plus x minus 3 plus x equal to 55. Equal to 55. So that's what is done here. So when you sum the numbers up, you get 35. 4x, if you add all the x together minus 3, everything you get 4x. 4x plus 35 equals to 55. So you take this one away from 55, you get 4x equal to 20, and therefore x equal to 5. So you'll be able to prove that x equal to 5 for that question. The B is find the probability that the selected members did not choose volleyball. Okay, the selected member did not choose volleyball. Okay, you know those who did. everything here chose volleyball. So you can find this number here. The number here is now 5 minus 3, which is 2. The number here is 5 plus 3, which is 8. Here is 5, because x is 5, here is 5. So we can fill up, we can redraw this diagram, put the real numbers instead of writing x minus. Fill the real numbers, and then when they say find the probability that the selected member did not choose volleyball, so we go to those, look at it. You see, in the second case, we have filled all the numbers. We filled all the numbers, and this is for volleyball. Those who did not choose volleyball are those who are never in this circle. Okay? Or you can say 55 minus those who chose volleyball. Those who chose volleyball are, look at those who chose volleyball here. Those who chose volleyball are 2, 8, 5, and 12. So we can add them together. This plus this is 20, 25, 27. They are 27. So to find those who did not choose volleyball, you can say 55 minus 27. 55 minus 27, that will give you 28. So it will be 28 over 55 for the probability. To become 28 over 55 for the probability. Now let's go to the C part of the question. It says find the probability that the selected member chose badminton, given that they had chosen table tennis. They chose badminton, given that they've chosen table tennis. Okay, first of all, we find those who have chosen badminton, given that they're also doing table tennis. Those who do badminton, given that they are doing table tennis, are what? Badminton and table tennis are what? What is the number? 8 and 5, right? Those who are doing badminton, given that they are doing, that's this 5 and this 8. This is the overlap between the two. Okay, between the two. 5 plus 8, which is 13, over this 28. This 28 that is here. This 28 that does not include volleyball. This 28 must not include the volleyball. Okay, over this 28. Okay, over this 28 that we got earlier on. Is that okay? So once we do that, we get the probability. Is that okay? Then the C part of the question, says, find the probability that the selected member chose badminton, given that they had not chosen table tennis. Given that they had not chosen table tennis. They have not chosen table tennis. They chose badminton, given that they've not chosen table tennis. Okay, I think this is the one we just did just now. They chose badminton, but they did not choose table tennis. Okay? So the D part of the question says, find the probability that the selected member chose volleyball. Selected member chose volleyball, given that they had already chosen other two sports. They chose volleyball, given that they have already chosen other two sports. So the number of volleyball that include other two sports, that is common to other two sports, is this 8. Okay, that is common to other two sports is 8. So 8 over 13. Why is it 8 over 30? Why is it, in this case, why is it 8 over 30? Because they chose badminton and table tennis. Because they chose badminton and table tennis. Is that okay? They chose badminton and table tennis. This one. They chose badminton and table tennis. So 8 over this 13. That's it for this question. So I think with this we've come to the end of this section. We've come to the end of this section. I think this is similar. Okay, so we've come to the end of this section. We meet in relative probability in our next class. Thank you.